Welcome to Haltech NSP Elite Training Part 25. In this training tutorial, we're going to break down the volumetric efficiency fuel injection strategy within our Haltech Elite systems, understanding all the ins and outs and how everything's calculated so you can work with this particular fuel strategy most effectively. Without further wait, let's jump in so we can check this out.
Okay, so let's get started. We're going to be taking a look at working with our speed density volumetric efficiency airflow strategy within our Haltech Elite using our NSP software. Now, we have a couple different choices for dialing in or fueling to our engine. So we can work with the VE speed density strategy, we can work with a mass airflow sensor, we can work with injection time based or fuel flow rate based type of tuning. My preferred way, and Haltech's base files that they always supply, are all going to be the speed density volumetric efficiency based tuning strategy. This is the more common and, in my opinion, best option to use when you're calibrating and working with your Elite system. It provides a mathematically based model so that we can have values in here that are not just arbitrary. We're not going to be just firing random numbers in here to increase or decrease our fuel. We are going to be very specific with our numbers, and we can do a check on our work. We can actually see if the values that we're dealing with here are properly estimating the airflow being ingested into the engine. We want these values to be mathematically correct, although if they're not, it's not the end of the world. But if we're doing things properly and we're scaling things and setting everything properly, we should find that the values fall in line with how I'm describing here in this tutorial. Now, I'm not going to get into setting up a base file and actually setting up the values in our table here in this tutorial or dealing with our breakpoints. I'll talk about that in the next tutorial, digging into a little bit more of the fine details of setting everything up. What I want to have you take away from this tutorial is going to be understanding the fundamental concepts here of dealing with this VE style strategy. So the very first thing I want to talk about here is our underlining equation that's going to be tying together both the fuel modeling and the airflow modeling, and that's going to be fuel mass is equal to air mass divided by target air fuel. Now, when we're talking about this and we're looking at this equation, we have things such as fuel mass or air mass. What does that actually mean? You might not be familiar with those terms. Well, air mass or fuel mass, or the mass of anything, is going to be the volume times the density. We need to know both the volume and the density to be able to properly characterize, in the case of air mass, how much airflow is coming into the engine, how much actual air mass is coming into the engine. Now, what does that actually mean? Well, the volume is something that we can understand. That's the volume flow of air. So that's our CFM of air being ingested in the engine. The density is something that you may not be as familiar with. So the density is going to be things like your elevation and your air temperature play a role in your density. Colder air temps, we have more oxygen molecules packed into the same volume of air compared to warmer temperatures where we have less oxygen molecules packed into the same volume of air. Because we have to account for that density, because it can affect how much fuel we need to deliver to the engine, because the engine's going to burn more or less oxygen depending on what the density is going to be, we have something called air mass. So air mass allows us to correct for both the volume flow and the amount of oxygen molecules that the engine is ingesting, that density portion. And that's where we get our air mass. Fuel mass is going to be the same thing. We can account for the volume flow of fuel that we need to bring into the engine. Also the density of the fuel based on the type of fuel we're dealing with. Petrol, ethanol, methanol all have to fit different fuel densities, so we want to account for that. And that's a whole nother topic that we're not going to cover right now. But just understanding the concept here of air mass or fuel mass, it's volume times density. So when we're talking about our air mass and we're dealing with our table here, these values are one part of our air mass equation that we need to essentially solve for in order to determine an accurate air mass value. Now, how do we figure out what the air mass is going to be based on these values that we find here? Well, if we break things down to determine air mass, to estimate our air mass, we need to know things like our map pressure, our volume per cylinder. We have a universal gas constant, 287, and we need to multiply that by the charge temperature, which is going to be essentially the air temp reading. And then all of that gets multiplied by the volumetric efficiency percentage coming from our table here. So we put that all together into equation. So it's going to be map pressure times volume per cylinder. So we specify the engine displacement, number of cylinders. Map pressure is coming from our map pressure sensor. We divide that by 287 multiplied by our charge temperature, and then we multiply all of that by this VE percentage. So the things that we have control over changing are going.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.